welcome back to the channel. The paper we are solving today is IGCSE Chemistry, May-June 2024, and this is the paper number 41. Alright, now let's start with the first question. Name the process that is used to convert sulfur dioxide into sulfur trioxide for the manufacture of sulfuric acid. Now we know that for manufacture of sulfuric acid, contact process is used. So, contact process should be your answer here. How will you obtain water from aqueous sodium chloride? Now, for this, you can just use simple distillation. Water and sodium chloride both will have different boiling points, so you can use distillation. Extract aluminium from purified bauxite. We know that electrolysis is used for extraction of aluminium from bauxite. So, electrolysis. Now, separate petroleum into useful substances. We know that petroleum gives us gasoline and petrol and diesel and bitumen. All these things we get from petroleum only. So, fractional distillation. Fractional distillation is what you need to write here. All right. Produce ethanol from aqueous glucose. Now, in organic chemistry, we have studied two methods to create alcohol. One is by fermentation, the other one is by addition reaction of steam with alkene, right? But in this case, this is a fermentation, so you mentioned fermentation where yeast is also required. Yeast helps in this, all right? Now, manufacture alkenes and hydrogens from large alkane molecules. So this is cracking. Cracking is where when you have large hydrocarbons, you break them to get the simpler, smaller, useful products. So this is cracking. Separate a mixture of soluble. So this we all know, chromatography. Make sure to write down chromatography. Now, question 2, table 2.1. Number of protons, we know it is the same, 17 will be here. Number of electrons is 17, so the neutrons will be 37 minus 17, which will come out to be 20. Alright, now this is copper plus 1 represents deficiency of 1 electron. So if protons are 29, protons will be 29 here, number of electrons will be 1 less, which is 28 because it is plus 1 charge. Now, in the third row, you have to identify the atom or the ion. Just look at the number of protons or electrons. If the number of protons and electrons are same, it's an atom. If they are not same, it will be an ion. Now, how do you know? Will it be a positive ion or negative ion? If it contains more electrons than protons, it will be a negative ion because negative represents excess electrons. And how do we identify the element? Atomic number is 16. You look at the periodic table, find the one with atomic number 16. It is sulfur, and since it contains 2 extra electrons, you put a charge of negative 2 or 2 negative, and then just write down 16, and 16 plus 17 will be the proton number, the neutron number will be, sorry, mass number will be 33. Mass number is the same as protons plus neutrons, so you add both of them. Now, next question. The question is about elements sodium and fluorine and the compound sodium fluoride. Sodium reacts with fluorine. Alright, write the symbol equation. So we just need to write down here the symbol equation for both of them. So Na plus F2, keep this in mind, fluorine is a diatomic molecule, so you need to write F2. And this will give us NaF since the valency of both sodium and fluorine is 1 only. Now you need to balance it, put a 2 here, put a 2 here, you will get the mass. Some properties of sodium fluorine and sodium fluoride are shown, alright. Explain why sodium conducts electricity when it is a solid. In solid, sodium contains mobile electrons or delocalized electrons. This is why. Alright. Complete the dot and cross diagram of a molecule of fluorine. Now for fluorine, we know that it is in group 7. It is a halogens group and the atomic number is 9. So the configuration will be 2,7. In order to be stable, it only needs 1 electron, right? And how many valence electrons does it contain? 7. So first of all, you draw 7 valence electrons. 1, 2, 3, 4, 5, 6 and 7th here. Then same for this 1, 2, 3, 4, 5, 6 and 7. Now this is just representing One electron they are sharing, so this is your correct answer. You just needed to share one electron between both of them, so they are sharing here. Deduce the physical state of fluorine at negative 200 degrees Celsius. Let's look at negative 200 degrees Celsius. So fluorine's melting point is negative 220 and boiling point is negative 188. Means it is converting from liquid to gas at this temperature and from solid to liquid at this temperature. So in between, it must be a liquid, right? So just mention. So just mention liquid, all right? And for the explanation, you can simply say that the negative 200 degrees Celsius is higher than negative 220 degrees Celsius. And what is negative 220 degrees Celsius? It is the melting point. So it must be a liquid then, all right? And then you can also mention that 200 degrees Celsius is between melting point and boiling point, so it must be a liquid. All right. Explain in terms of structure and bonding why sodium fluoride has a much higher melting point than fluorine. Now, sodium fluoride is an ionic compound, and fluorine is just a covalent molecule, right? So you can just mention sodium fluoride is ionic compound where strong electrostatic forces of attraction are present between oppositely charged ions, opposite charged ions. For example, Na plus and F minus, they both are negative ions, both are positive and negative opposite charged ions. So they will have strong electrostatic forces of attraction between them. And for fluorine, you just need to mention it's a simple covalent molecule with weaker attraction between particles. All right. So for fluorine, you just need to mention weaker attraction between particles. It's a covalent molecule. This is what you need to write. All right. Dilute aqueous sodium fluoride undergoes electrolysis. Hydrogen is produced at cathode. State what is meant by the term electrolysis. So electro means using electricity. Lysis means you are trying to break something. Lysis is a word used a lot in bio. There are a lot of enzymes which have the word suffix as lysis. It simply means to split up or break something. So electrolysis simply means breakdown of ionic compound into constituent ions by passing electricity through it in molten or aqueous state. I understand you might not be able to understand what I'm writing, but just hear me out properly. I'll repeat again. Breakdown of ionic compound into constituent ions by passing electricity through it in molten or aqueous state. This is what you need to mention. All right. Write an ionic equation for the production of hydrogen at cathode. So it will be 2H plus 2 electrons giving H2. Now, in case you're confused about it, just think about this. The product is hydrogen gas, right? And we know that hydrogen ions must be going there. So hydrogen ions are going there, plus one charge is there, you add one electron to it. But do we have only one hydrogen or we have two hydrogens? Hydrogen in elemental form is diatomic. So you need to make all this times 2, 2 electrons. This is why this is the answer. Alright, now question number 4, it's an equilibrium question. Color is given. Let's start with the first question. State what is meant by the term equilibrium. We know that rate of forward reaction is equal to rate of backward reaction. Do not write in short form like me, write properly. Then second statement will be concentration of reactant and product is constant. Or you can also mention no longer changing, totally your choice. It means the same thing ultimately. No longer changing or constant is ultimately the same thing. The pressure of the mixture is increased, all the other conditions stay the same, the position of the equilibrium is not changing. So they are trying to tell you that we know that pressure changes the position of equilibrium, but specifically in this equation, pressure is not changing the position of equilibrium. Then they're asking you, why is it not changing? See, pressure changes the position of equilibrium only when number of gaseous molecules are different on both sides, right? Pressure changes the position of equilibrium only when number of gaseous molecules are different on both sides. But in this case, if you check on the reactant side, two gaseous molecules are here, and on the product, one gaseous molecule, another gaseous molecule. So it is 2 is to 2 only. So the number of molecules are same. Now, what do you need to write? You just need to write because the number of gaseous molecules is same on both sides. Part of this question, suggest why the color of the mixture of gases turns darker purple. Just think about it. If you're increasing the pressure, you are squeezing in the molecules in less space. You are just increasing the number of molecules in the same volume, right? And HI is colorless. This is also colorless. So the color of iodine will dominate. It will show, right? So you can just mention iodine molecules are forced closer together. Now they will start showing their color. Or you can mention same number of iodine molecules in smaller volume. You are increasing pressure, so volume is decreasing. The now purple color will show. The temperature of the mixture of gases is decreased. The mixture of gases turns lighter purple. Alright? Means now it was showing darker purple color. Just think about it. It's a good question. It's a simple question, but it's a good question. A lot of children make silly mistakes in this. Currently, the color is darker purple, and then in part C, they're saying when you decrease the temperature, so I'll write it down here. Currently, it is darker purple, but when you decrease the temperature, it is converting to light purple. And darker purple color is given by which gas? Iodine, which is present on the product side. So it simply means when you are decreasing the temperature, the reaction is going backwards. It is going away from the darker purple color. And now we know that in endothermic reaction, when you decrease the temperature, backward reaction is favored. So this can tell you that this is an endothermic reaction. Because when you increase the temperature in endothermic, forward reaction is favored. When you decrease the temperature, backward reaction is favored. Deduce the oxidation number of iodine I in HI. We know that H is plus 1, iodine, let's keep it as X, is equals to 0. The total charge is 0. So X will be negative 1. Alright. Now this iodine is present in elemental form. In elemental form, the oxidation state is always 0. So you just need to mention 0. Methanol is manufactured by reacting carbon monoxide with hydrogen. Alright. The rate of formation of methanol increases when a catalyst is used. Alright. Choose from the list the element that is most likely to be used as a catalyst. We know that transition metals are used as catalyst. Is this a transition metal? No. This? No. This? Yes. This? No. This? No. What is the answer? Copper. Alright. You have to draw a circle, so just mark a circle. State the effect of the position of equilibrium when a catalyst is added. Now, catalyst increases the rate of forward reaction as well as backward reaction, but it does not affect equilibrium. So, no effect. A catalyst does not affect equilibrium. Alright. State the effect that catalyst has on the activation energy. See, catalyst decreases the activation energy. This is true. It does not affect equilibrium. So, you just mention decreases the activation energy. Write it in proper words. I'm just using short forms. Question number 5. Lead bromide is an insoluble salt which is made by precipitation. Now, for precipitation, according to our syllabus, precipitation or insoluble salt, precipitate is formed by using two soluble salts. Just check your notes again, go through the course book that you use. You will find it there. Two soluble salts are used. Now, we have to think of two soluble salts which can give us lead bromide. Now, we know that all span salts are soluble: sodium, potassium, ammonium nitrate. So let's use lead nitrate first of all. Yeah, we can use lead nitrate. So mention lead oxidation state to nitrate. Now the question is, from where will we get the bromide? So use sodium bromide, because sodium salts are also soluble. So sodium bromide. Describe how to produce a pure sample of lead bromide from the mixture of aqueous solutions in A part 1. So they're just asking you the final steps of precipitation. What we need to do is filter the precipitate, filter the precipitate, and then wash it with distilled water. Alright. Now, in case you're wondering why wash it with water, because some soluble impurities always remain. If you want to get rid of these soluble impurities, just wash it with water. They will get washed away with soluble, because they're soluble, right? Write an ionic equation for the precipitation reaction which produces lead bromide. Now, this is again a similar question. We have also done this in paper 43, similar. And two methods are there. Let's use the simplest one now. Lead bromide, what you need to do is just write it as a product first. Lead bromide will be this, right? Now, simply think about the ions from which lead bromide is made. According to me, it is made from Na plus Cl. Do you think so? No. It's very simple that lead bromide must be made from lead ion, which is Pb2 plus, and made from bromide ion, which is Br negative 1. You will have to put a 2 here in order to balance this. Write aqueous here, and solid here. This is the answer. You will get all 3 marks for it. Alright. 1 mark you get for writing the product properly, 1 mark you get for writing the reactants properly, and 1 mark you will get for writing the state symbols. So if you miss state symbols, you will get only 2 out of 3. Now, how I have done this? Just look at the compound and think of the ions it might be made from. It's very simple. It's made from lead ion and bromide ion. So just write them. When iron sulfate crystals are heated strongly, sulfur dioxide gas is given off. Alright. Describe a test for sulfur dioxide gas. Now, a test for sulfur dioxide gas is using acidified aqueous potassium manganate, and the oxidation state of it is 7. Observation, it changes from purple to colorless. You must have done this practical in school. Currently, it's not a practical paper, so we just need to remember the values, the observations. All right. Now, complete the equation for thermal decomposition of hydrated cobalt nitrate. Now, it's again a simple maths question. I consider these questions to be maths questions only. Just count the number of atoms. So, first of all, let me write down cobalt here. Hmm. Cobalt here, nitrogen here, hydrogen here, oxygen here. Now, cobalt is times 2, so 2 atoms of cobalt. From this, we know that we have to put a 2 here. Nitrogen is in bracket of twice, and the whole compound is also multiplied by 2. So it should be 4 times. Nitrogen is 4 times. Oxygen is 3 here, and times 2 here, which is 6, and then times 2 here again, which is 12. So 12. Hydrogen is times 2 here plus times 4 here. So this is 8. Then times 2 again, which is 16. Now in oxygen, H2O also contains oxygen. And one H2O contains one oxygen. 4 H2O will contain 4 oxygen. And this is also times 2. So 8 oxygen again. So 20 oxygen atoms overall. 4 cobalt, 2 cobalt, 4 nitrogen, 16 hydrogen. Now, in order to balance nitrogen, what number should we put? 4 nitrogen atoms are there, put a 4 there. Now for hydrogen, 16 are there. This is H2, so put a 8 here. All this was not usually required, but if I have to explain this to you properly, this is required. All right, you can do it without writing all this. Now, hydrated cobalt sulfate produces water when it is heated. Now, this question is exactly similar to the paper 43, which we did 2-3 days ago as well. The formatting of the question is exactly the same. Describe what else the student should do to ensure that all water has been given off. Now, in if you want to make sure that all water is released, so you just heat it again and reweigh continuously until you get constant mass. See, if the mass is not changing anymore, it clearly means all the water is gone away, right? Until you get constant mass. Now, the stoichiometry question, our favorite. In an experiment, 1.405 grams of this much was used, all right. Determine the value of x. So, ultimately, we have to find the value of x. Let's start with the basic questions. Calculate the number of moles of COSO4 that remains. The remaining mass is 0.775. The mass is, molar mass is 155. So, you do 0.775 by 155, your answer will come out to be 0.005. Calculate the mass of H2O given off. Mass of H2O given off. Now just think about it. The mass of total hydrated compound was this much. Then what you did is you started heating it to remove the water. And after the water was removed, you were left with only this. So what is the mass of water remaining? 1.405 minus 0.775. Right? And it will come out to be 0.63 grams. Calculate the number of moles of H2O given off. Now, you know the mass released of H2O. What is it? 0.63. So, divide 0.63 by the molecular mass of H2O, which is 18. So, 0.63 over 18 will be 0.035. Alright? Determine the value of X. Determine the value of X. Now, for this, let's write down moles of cobalt sulfate and moles of H2O. Moles of cobalt sulfate are 0.005. Moles of H2O are 0.035. Alright. Now, if you check the relation between them, see, look at the equation here. Cobalt sulfate is 1 and H2O is X. So, the ratio between them is 1 is to X, right? So the ratio is 1 is to x. Now you can use any method of maths, you can divide them. You get my point? So if you divide them, just a minute, let me use the calculator. 0.035 divided by 0.005. The answer is coming out to be 7. So 7 is the answer. Very simple. Now, next question. It's a extraction of iron question. Coke and iron are added to, at the top of blast furnace. Name one other substance which is added. Calcium carbonate is added, which is CaCO3. So just mention limestone, or you can also mention calcium carbonate, your choice. Name the substance that leaves the blast furnace at A. Now, for this, you need to study the diagram properly. Every labeling you should be able to tell. And we know that the point A is molten iron. So you just need to mention molten iron goes out from here. Slag is produced from an impurity by iron ore in iron ore. Name the impurity. Now we know that calcium oxide, when it reacts with SiO2, then CaSiO3 is formed, right? And the impurity SiO2 is nearly sand. So the impurity is SiO2. You can mention silicon dioxide, or you can mention silicon oxidation state 4 oxide. Both are the answers. Name two substances that react together to produce the high temperatures in the blast furnace. Now, when combustion reaction takes place, then the temperature increases. And we know that carbon reacts with oxygen to form CO2, which increases the temperature of blast furnace. So, you need to mention coke or carbon which reacts with oxygen. Name two waste gases that leave the blast furnace. So carbon dioxide leaves the blast furnace, nitrogen gas leaves the blast furnace, or argon also leaves the blast furnace. Zinc is produced from zinc oxide in a furnace. The zinc is produced as a gas, it then forms molten zinc. Suggest why zinc produced inside the furnace is a gas. Now just think about it. If the temperature of furnace is nearly 100 degrees Celsius, and the boiling point of zinc is, just assume, if the temperature of the furnace is 100 degrees Celsius and the boiling point of zinc is 80 degrees Celsius, what do you think, in which form will it be present? Obviously liquid, right? Molten form. So suggest why zinc produced inside the furnace is a gas. What can we write here? Because the temperature in the furnace is higher than boiling point of zinc. Very simple. State the name of the physical change that occurs when gaseous zinc is converted to molten zinc. So they're just asking gas to solid. What is gas to solid? Condensation. Zinc is used to coat iron to prevent rusting, we know, and we know that the process is called as galvanization. When the zinc coating is scratched, the iron underneath does not rust. Explain why the iron underneath the zinc does not rust. See, the whole idea of using zinc to protect iron is that zinc is more reactive, so it will get oxidized first. It will react first. So you just need to mention zinc is more reactive than iron. Why am I not able to write? Give me a minute. So you need to mention zinc is more reactive than iron. So zinc oxidizes, or you can mention loses electrons first. See, when we are saying metals react, it simply means they're getting oxidized. Metals form positive ions, so they lose electrons. Zinc oxide neutralizes both acids and bases. Amphoteric oxides. We know that the oxides which can act as base as well as an acid are amphoteric oxides. Al2O3 is another example that we need to remember according to our syllabus. So keep that in mind as well. Now, when zinc oxide neutralizes aqueous sodium hydroxide, sodium zincate is formed. The formula of zincate ion is ZnO2 with a charge of -2. Now just think about it. They are telling you sodium zincate is formed from which zincate ion has a charge of ZnO2 -2. We know that sodium has a charge of +1, right? So just write 1 below sodium and 2 below ZnO2. Cross multiply. You will get Na2ZnO2. Alright. Name the zinc compound that forms when zinc oxide neutralizes dilute sulfuric acid. When zinc oxide reacts with sulfuric acid, zinc sulfate is formed. So you just need to mention zinc sulfate. Sulfate. Question 7. It's a question regarding the empirical formula. See, the total percentage is adding up to be 100%. The total percent is adding up to be 100%. So you can directly take carbon is 82.76 grams, hydrogen is 17.24 grams. What is our next step? Divide with the atomic mass of carbon, divide this with the atomic mass of hydrogen to get a simplified ratio. Give me a minute, I'll use the calculator. 82.76 divided by 12 is coming out to be 6.89, and this will stay 17.24. Now what is the next step? Divide with the smallest number of moles. So 6.89 divided by 6.89, this will give us 1. 17.24 divided by 6.89. So 17.24 divided by 6.89. This is coming out to be 2.5. Now, this is the simplified ratio, but ratio cannot be in the form of decimals, right? How can you say 1 is to 2.5? Not valid. Atoms cannot be in the form of decimals. So, we need to just multiply both the numbers with 2 It will turn out to be C2H5. This is the simplified ratio in whole numbers. C2H5. Now, compound B has the empirical formula this much, alright. Now just think about it. There is another compound, they're saying it has empirical formula CH2. And then its molecular formula mass is 70. So you need to figure out the molecular formula. Will it be C2H4, C3H6, C4H8, C5H10? What will it be? So how you do this is find out the mass of empirical formula. It will be 12 plus 2 times 1, which is 14. Now check the ratio between 14 and 70. Is it exactly divisible? So 70 divided by 14 is coming out to be 5. Means the molecular formula is 5 times bigger than the empirical formula. So it will be C5H10. Very simple maths. Now, next question. This is a question on polymers. This is showing a section of polymer. Alright. Draw the displayed formula of the monomer. Now, for this, first of all, we need to figure out the monomer. And you can see that this unit is repeating. And when you studied addition polymers, you know that the double bond is broken to form the polymer. Now we are going from polymer back to the monomer. So you need to form the double bond here. So first of all, what I'll do is I'll write it as it is. I'll just put a double bond in between. So this should be your monomer. But is this the answer of this part? No. Because they're asking you in displayed formula. Now what you need to do is just draw the carbon double bond carbon here. Hydrogen you can draw here, that is fine. But CH3 you have to open it up now. You also need to show CH3's bonds. So 3 hydrogens on this CH3, then 3 hydrogens on this CH3 as well. This is the answer. Now how do you name this? See, the total number of carbons are 4, right? So I will write but. Now what is the position of double bond? If you start from left, 1, 2, it is starting from second carbon. If you start from left or right, you will get the position to be second position, right? So but dash 2 dash ene. This is the name of the monomer. How did I do this? First of all, look at the number of atoms. There are 4 atoms. 4 atoms is but. Now there is a double bond, so it must be an alkene. But we need to represent the position. So but 2 ene. 2 is telling me the position of double bond. Alright, I think you get this now. So this is our last question. Let's finish this. The equation is given for 1:1:1 ratio, and this is a cracking reaction. All right. So the product should be 1:1:1. Now it's just a simple maths then. 3 carbons have been used up here out of 11. What is the remaining number of carbons? If 3 have been used up out of 11, then what do you think is the remaining number? The remaining number must be C8, and hydrogen 6 plus 2 8 out of 24. 8 out of 24 have been utilized, so it will be C8H16. This is the answer. Now, carboxylic acids and esters contain carbon, hydrogen, oxygen only, right? An ester X and a carboxylic acid both contain 3 atoms. So it's just that ester X and carboxylic acid Y both contain 3 carbon atoms. X and Y have the same molecular formula. Alright. State the name given to the compounds with the same molecular formula but different structural formula. These are called as structural isomers. This is the definition itself. So these are called as structural isomers. Now, esters are made by the reaction between carboxylic acids and alcohols. Ester X is methyl ethanoate. Now, for this, if you just want to name the acids and alcohols, there is no need to draw the structure. It's a lengthy process. I have taught you a short trick for this. Just look for the aryl group. This will give you the alcohol. So if it is methyl, the alcohol will be methanol. And if it is ethanoate, the acid will be ethanoic acid. You can practice it out later on. It will always give you the correct answers. The OAte comes from the acid, aryl part comes from the alcohol. So if it is methyl ethanoate, methanol and ethanoate will be ethanoic acid. So this is what you need to write here, ethanoic acid. Draw the displayed formula of carboxylic acid Y. Now do not make the mistake here of drawing the structure of ethanoic acid. They're asking for carboxylic acid Y, and carboxylic acid Y contains 3 carbon atoms. So they're asking you to draw the structure for propanoic acid. Now see, we know that carboxylic acid is C double bond O, OH. Prop means 3 carbons. So draw 3 carbons, then O, OH, then just satisfy the valency. Put hydrogens there. This is your answer. Alright? Now, we're done with the paper. In case of any doubts, feel free to let me know in the comments section. Next paper we'll be solving will be a MCQ paper that will be uploaded tomorrow.